one wrong pointer and the entire list is gone. Let's reverse a linked list step by step. Here the key is pointer control. Here is our initial linked list, and as we know, every linked list starts with a head pointer. So here is our head pointer. Given the head of the singly linked list, we need to reverse linked list in place. And we don't want to create any new list. We cannot use any extra memory and no recursion. So these are the constraints to solve this problem. So to reverse a linked list, first node should point to null. Then this node's next should point to the first node. This node's next should point to this node. And head should point to this node now. Let's develop our reverse list function. It accepts input as a head node and returns a head node of a reverse list. To reverse a linked list, every node's next should point to its previous node, right? Let's use two pointers, a previous pointer which points to null to begin with, and a current pointer which points to a head node to begin with. Struct node star previous equals to null to begin with, and struct node star current, it will point to head node to begin with. Now to reverse a linked list, current next should point to previous node. Then we move forward the previous to point to current node. Previous will point here and current node will point to the next node. Again, current next will point to previous, which is pointing to this node now, and previous will move forward to point to the current node, and current will move forward to point to the next node. So current will move here. Again, current next will point to the previous node, which is pointing to this node now, and previous will move forward to point to the current node. Previous will move forward here, and current will move forward to point to the next node, and the next node is null now. So current will point to the null, and once current reaches to the null pointer, basically list reversal is complete. So if you notice carefully here, the previous node is pointing to the last node. So previous node will become our head pointer. There is one issue here. Let's see how to fix that as well. As we discussed, to reverse the linked list, currents next should point to previous. So let's write it down. Currents next should point to previous. But once we do this, can we move forward current to point to next node? No, right? Because we lost this link. We don't have a way to move forward now. So before we do this step, we need to basically save the next pointer. So let's define one next pointer. Struct node star next. To begin with, it points to null, and in every iteration, first we need to save the next pointer. So next should be currents next. Now with this statement, next pointer will point to this node, which is currents next, and with this statement, currents next will point to the previous node. Then we move forward the previous to point to current node, and current to point to next node. So current will move here. So previous equal to current, and current to next node. And in next iteration, again we need to save the next. So next will point to this node, next will move here. The currents next will point to previous, currents next will point to previous node, and previous will move here. So previous will move here, and current will move here. So previous equal to current, current equal to next. And this process will repeat until current reaches null, as we discussed earlier. So while current is not equal to null, current is not equal to null, we need to repeat this process. And once we come out of this while loop, our previous node is going to point here, as we discussed earlier. Once we come out of this loop, previous is going to point to the last node. So that is our new node. So return previous, return prev. Let's see the working code now. Here is our reverse list function implementation. This accepts input as a head node and returns a pointer to reverse list head node. we will analyze this function in a while, but before we do that, let's understand what main function is doing. Here is our main function. It creates a linked list with 4 elements, 10, 20, 30 and 40, 4 nodes. And it prints all 4 nodes, and then we call a reverse list function with a head pointer, and it returns a new head. So we are printing here the reverse linked list, and output should be 40, 30, 20 and 10. Let's compile this code and run. Let's run the code. So here, as you can see, the input list is 10, 20, 30, 40, and the result is reverse list 40, 30, 20, 10. Now let's analyze this reverse list function carefully. To begin with, we have a previous pointer which points to null. So prev is pointing to null, and current is pointing to a head node. So current is pointing to the first node, which is head node, and next, to begin with, pointing to null. Now in this while loop, first we need to save the future node, which is the current's next node. So with this statement, next equal to current's next will point here. Now what we are doing, current's next equals to previous, which means current's next will point to previous node to reverse the list. Now after this, we move forward the previous to point to current. So previous is pointing to current, and current is pointing to next. So current will move here to point to next node. Now at this point, current is not null, so we again move forward. So next will point to current's next. So next will point to this node next, which is current's next, and current's next will point to previous. This is current, current's next will point to previous, and previous will move forward to current. So previous will move forward to current, previous, and current will move forward to next. So current will move here. Again, current is not null, so we move forward again. So next will point to current's next. So next will point here, next. Again, current's next with this statement will point to previous. Current's next is previous, and we move forward the previous to point to current. So previous will move here, and current will move here. Again, current is not null, so we move forward again. So next is equal to current's next. So next will point to null element now. The current's next is equals to previous. Current's next is pointing to previous now. Previous equal to current. So previous will move forward here, previous, and current equals to next. So current will point to null. The moment current points to next, while loop will break, and if you notice carefully, previous is pointing to this last node. So we return the previous because this will be our new head node. Remember this, we need to save the future, then reverse the link, then move previous, and then move current. If you found this video useful, please subscribe.